I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Today I want to talk about polygons. This is section 6, talking about two-dimensional objects. Geometry MG.A.3 says, apply geometric methods to solve design mathematical modeling problems. Many of those problems involve polygons. I can identify and name polygons. I can find the perimeter, circumference, and area of two-dimensional figures. Now, there are many polygons. Circles are not polygons because they don't have any straight lines, but we have triangles, have 3 sides. We have squares and rectangles that have 4. Squares and rectangles, parallelograms are all considered quadrilaterals, quad meaning 4. Many of you know what we would call a 5-sided figure. That's a pentagon. A 6-sided figure might be a hexagon. An 8-sided figure looks a lot like that stop sign that some of you roll through at the end of the street. It's red and it's got 8 sides. But when we talk about perimeter and area, we're talking about 4 basic shapes. Let's start with the rectangle. The perimeter of a rectangle is twice the length plus twice the width. And our length here is set on a graph, so we have to count to figure out that this side is 2 and this side is 6. So there we get perimeter equals 2 times 2, which is 4, plus 2 times 6, which is 12. The total is 16. Perimeter is the distance around. If you had this rectangle in your backyard, you needed to buy fencing, you would need 16 feet or 16 square units of measure. Now let's try the area. The area will be 2 width, length. Area is equal to 2 times 6, 12. That's a rectangle. Now, one special rectangle looks a lot like a square. I've got the perimeter here as 4S, but it could just as well be 2L plus 2W, because a square is a rectangle. And the area could be length and width. Length times width, or in the case of a square, this square is 12 by 12, its perimeter would be 4 times 12, 48. Its area would be 12 times 12, which is 144. And the perimeter, once again, would be equal to 48, 4 times 12. Now, the area of a triangle is half a rectangle. So instead of length times width, you get base times height. The perimeter of a triangle, there's no formula, but you have 3 sides on a triangle, so you would add them. Here I would add 8 and 17 and 15. If you add 8 and 17 and 15, I think you get 40, but check my math, because Professor Pi can make a mistake. When you add 17 and 15 and 8. You're adding 3 sides of the triangle. This triangle is equilateral. This triangle is 10 by 10 by 10. So the perimeter over here would be 30. Now let's go with the area. It's 1/2 of 15 times 8. It's 1/2 of 8 times 15. Half of 8 is 4, and 4 times 15 is equal to 60. Now, over here, half of 10 is 5, 1/2, the base. Half of 10 is 5. 5 times 8.5. I said 8.5 and wrote something else. 8.5. That's 42.5. Once again, don't just take my word for it. 42.5. Don't take my word for it. I make math mistakes, just like everybody else that makes math mistakes. 5 times 8.5 should come out 42.5. Now, this is not a polygon, but the next one's the circle. For our purposes, pi is 3.14. That symbol pi is 3.14. So now with the radius being 6, let's find a perimeter. And we don't have a perimeter of a circle. We have circumference, which is Greek for perimeter, distance around the circle. Think of this as a hula hoop. The distance around the hula hoop would be 2 times pi times r, and r is 6. So the radius, if the radius is 6, then our circumference of the first one is 12 times pi. 12 times 3.14. What's 12 times 3.14? It's about 38. But that's why you have a calculator. I expect you to know the 3.14 times tables. I do expect you to know the 12 times tables. If it were 12 times 3, I would expect you to know that it was 36 without reaching for your calculator. And what would the area be? Pi r squared, the radius is 6. So 6 times 6 would be 36 pi, or 36 times 3.14. Get a calculator, and it's 36 times 3.14. That would be the area of your circle. Now, you know the area of a circle and a square and a rectangle and a triangle, but sometimes you get weird figures. I'm not even sure what this is, but I think it's got 1, 2, 3, 4, 5, 6 sides, which would make it a hexagon. It's not a regular hexagon because all the sides aren't equal, but it's a hexagon. It's got 6 sides. If you could draw a line right here, straight down, you would have one rectangle that was 40 times 40 times 22. That is, if you draw this straight line right down, you get a rectangle. And then you would have another one. This side would be 50, subtract 22, which would be 28. So we're going to add 28 times, that is, this is 28 by 22, right? And that would be the area of this weird figure. Many times you can take a weird figure and break it down into rectangles, squares, and triangles. And that's how you solve it. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.